This is Math 151, section 04F, F standing for flex, in case we switch to remote delivery midway through the semester. Despite what Moodle says, you can call me Brad. So you've probably gotten one, maybe a lot more than one email from me. And these emails, well, if you've misplaced the emails, I also made them announcements in Moodle, so you can check Moodle as well. But it's really important that you go through these emails, as they do explain the structure of the course, as well as getting set up for the class. So, for example, how to set up my math lab and everything you need to know, as well as the first assignment as well. I also shared a Google Drive folder with you. We can explain that in a little bit when I talk about the workbook. But besides for that, for my Google Meet people, I'm going to just present my screen just to show you what I'm looking at. So last I looked, a good 30-ish people have signed up already, which is great, considering there's a class size of 37. So the majority of you should already be able to see this interface that is currently on my screen. And my math lab is the primary portal that we will use to do everything in this class. The only thing I use Moodle for is announcements. That's it. Everything else is in my math lab. And yeah, if you haven't noticed already, some of the important tabs, assignments is the one I currently have clicked on here. The blue circle assignments are the homeworks, and of course quizzes are appropriately named. And so as long as with their corresponding due dates, I think the first assignment is due Friday on the stuff that we're going to talk about today. So make sure you have that down. I did post the course notes. I made a tab for it in my math lab called course notes, and these notes are everything that pertain to the first unit assessment, as they call it, pretty much the first test of the class. So all the notes that I have here will pertain to the first test. If you look under course documents here, you'll find the syllabus, you'll find a daily schedule, which may or may not be subject to change, and the procedure for submitting workbook pages and the first assignment here. So if you read my emails and/or the announcements in Moodle, you will know, or you should have read about these by now. So what I'm going to do is I'm going to talk about the syllabus. Syllabus is rather lengthy. I can condense it down to a few pretty much main points. So of course, Math 151, this is college algebra. And start off with the required materials. So the first three things there, the computer with strong, reliable internet connectivity, the webcam, and the fees, that all pertains to the final exam for now. It definitely pertains to the final, because the final exam will be an online exam. You will take it through a proctoring service called ProctorU. Some of you may have experience with it, some of you may not, but this is mandatory. And so a computer webcam is perfectly fine. You don't have to go out and buy a webcam such as the one I have mounted here. The fee, yeah, it's $19.75, but again, that's all pertaining to the final. This is contingent upon whether we switch to online delivery before or after the midterm, if at all. If the pandemic gets really bad and we have to switch to remote delivery before the midterm, then the midterm will also require you to have a webcam and pay the fee and the computer with the strong, reliable internet connection. So that is a contingent point, and you can consider getting those materials now, or you take the risk and just hope that the pandemic doesn't get bad. At least the recent numbers I saw, the numbers are in steady decline from NOLA.com and a few other sources. So that's good news. The main thing you need to get is a TI-30X. That sounds kind of technical. I'm going to show you all what it is. For those of you in class, get this calculator. Again, the name of it's in the syllabus if you forget. People online. It's for people online, this is the calculator you need to get. So if you don't have it already, some of you may have used this calculator in high school. This is actually the one I used in high school. So it's a good calculator. So additionally, so that's the calculator. I've had a few of you ask about the workbook. And the workbook, so it's back ordered. Whatever the case is, I don't even have one. You would think I would need one. I don't even have one. I'm not going to be a stickler about the workbook. In fact, the plan so far is that I'll just post the first few pages of the workbook for now. So if anything, you're not going to need it this week. So, I'm pretty forgiving about that. So maybe by next Friday, but again, that'll be a rolling thing. Mainly the calculator, because it's going to help you a lot. So that's the materials, email requirement. Everything's through your Southeastern email. A lot of you online or in person, a lot of you are incoming freshmen. As such, you may still be used to using a personal Gmail account, or some high school email, some other email. So everything here is done through Southeastern. And this is more streamlined by the fact that since we do so many things online, we use so many Google products, and those products such as Google Meet, for those of you online, this is, everything's linked to your Southeastern email. If you email me using your personal Gmail, I'm just going to respond back saying, don't do that. Use your Southeastern email. And same with the Google Meet sessions. For those of you here now, you have to join using your Southeastern email. For a lot of you, on your phones by default have your personal Gmail account by default. So if you try to do something through the phone and it's restricting access, think that your phone might be defaulting to your Gmail account. So something to keep in mind. The remote submission of the workbook pages, that's what the first assignment is for. The midterm and the final, we'll talk more about that when the time comes. The course grading layout, I think it's pretty straightforward. It makes sense that the midterm and the final are so high because those are proctored exams as opposed to everything else, which is not proctored. Contrary to what you heard, actually, I don't know why I said contrary. In contrast to the traditional layout of the class, rather, we do not have a tutoring lab that is required. Some of you may have heard about it, whether good things or bad things. There is no tutoring lab aspect to this, like there are, because obviously having a bunch of people in a small room is not very, it's not very good in these times. So the course structure, the assignments mainly are predicated upon homeworks, quizzes, workbook, and tests. And all the grade distributions are outlined as such. As you can see, we're going to go over a lot of stuff. Academic integrity, don't cheat. Due dates and makeup, you know how that goes. Since so many things are done online, pretty much the ability to successfully petition for me to move back one of your assignments due to something is relatively low because things are due online and you can do everything online. So, but if you do have a serious medical issue, you do need a doctor's note or some university excused note. The face masks, seems like everybody is doing fine. I keep trying to put mine over my nose and it comes right back down. I hope you all don't mind. If so, I'll be stringent about it. You'll just see me give up halfway through the lecture, probably. Working from home, like I said, you can do everything from home. At any point in the semester, you could just stop showing up and do everything virtually. If you're sick, don't show up here. Safety is the paramount concern here. So at any point, you could just decide to go virtual, or for the virtual people, you can decide to show up to class, provided, of course, you're not sick. Please don't show up sick, because that's, of course, bad. Everything else, if you need accommodations, well, that is not the correct accommodation place. If you search for the accommodations, it's in Tinsley Hall. Do you need any accommodations for the class? But yeah, if you just Google accommodation Southeastern, then you'll find it. And yeah, that's pretty much it. That's the syllabus. So yeah, mainly the calculator, kind of structural outline of the course, all that fun stuff. So good, cool. And I've been trying to be very good about responding to emails as well. Any of you have any questions? So I think I've been pretty good about them so far. So under course documents as well, there's a daily schedule. I think I just pointed to this. So I think other than that, let's go ahead and start the class. So like I said, I posted the course notes on my MATLAB. These notes are for everything leading up to the first test. So everything online is everything leading up to the first test. So my in-class lectures go predominantly off of everything you see in these notes. It helps me because I don't have to write down questions, and it helps you all because it gives you a structure of what I'm talking about, and you don't have to write as much. So to start off, well, we're going to naturally talk about functions. You might have heard the word functions before. You might not have. In any case, there's a way of thinking about functions that I thought about a few years ago. I think it makes a good analogy, maybe not an analogy, a good representation of what a function, how a function can be applied. So, and I wrote a little description here. I'll kind of give a verbal interpretation of it. So consider a car that's traveling, some amount of time, it's traveling some speed. So I feel like this is a fairly practical thing to all of us. A lot of us drive or have been in a vehicle before. So a car's driving over some amount of time. So after 3 seconds, if I were to ask you how fast the car is going, it wouldn't really make sense for you to give me 2 different miles per hour. And you might think, what a silly thing to ask. 2 miles per hour at the same time? That's sounds a little weird. Exactly, it sounds a little weird because if after 3 seconds, a car is going both 30 miles per hour, 45 miles per hour, well, that doesn't really make sense. It's got to be one or the other. So to slowly incorporate some terminology into it, the input of 3 seconds can only correspond to, at most, 1 output, which is the miles per hour. So using that sort of interpretation, this builds up to the idea of a function. And if you notice, a function I have the technical definition here, but if you notice, for those of you at home, I'm going to just use my mouse to hover over it. So I use X and Y. It's a bunch of technical jargon. It's a relation, all right, so it connects some stuff together, like seconds and miles per hour, that associates one element of X to exactly one element of Y. So that's exactly what I said. So 3 seconds can only correspond to 1 mile per hour, either 35 miles per hour or 45. The collection of inputs is called the domain. The collection of outputs is called the range. These are terms that will come up later. In fact, in example 1, immediately. So, and also, depending on what your background is, we notate functions as f of x. So where my mouse is hovering right now, excuse me. So we generally notate functions as f of x, which is where my mouse is hovering right now, where x is the input and the output is the value. Okay, cool. So we move on to example 1. It says state the domain and range for the following relations and then determine if this gives a relation or a function or not. So, in fact, the first thing I need to do is this interesting thing I figured out. All right, cool. So, what you see here, depending on what your background is a collection of ordered pairs. So it's these set of parentheses, and these ordered pairs have an x value and a y value, an x value and a y value, an x value, and so on and so forth. So the domain is the collection of x values. Okay, well, that sounds pretty good so far. So if we were looking for, I'm a little bit clunky with the stylus. I'm still trying to figure it out. So this is supposed to say domain, I swear. So the domain, it's simply the collection of x values. So how do we collect them? Do we just list them? Well, really, yes, but we also use this curly brace notation. And you notice it. So that's a curly brace. You can see an example of a curly brace right above it. And with that, we're going to start listing off the x values. So that ordered pair of 4, 5. 4, because that's the x value. And then I see a -7. And then 8. So virtually, I'm listing off the first value in every ordered pair, because that's the x value. And then I see another 4 for the last pair, but I already have a 4. So I'm not going to write it again. And that should be a closed curly brace. Okay, that's the domain. They don't have to be in order, but just get rid of any duplicates. All right, so let's move on to the range. So this is the range. I know it's kind of hard to see. That is the range. And so we're going to do the same thing as before, but we're going to list off the y values. So with the pair of 4, 5, we would list the 5. And then the next one, -7, 5, we would list off the 5, but we already have a 5, so we skip it. And then I see a 6 and a 16. Just like that. So don't write any duplicates, if there are any. And I wrote off all the y values. Now we ask, is this a function? Well, Let's think back to that example we had. So if you thought about each one of these x values as being an input or amount of seconds, it can only correspond to one output, or say miles per hour. So here, some glaring issue I see is if we use that comparison, it says after 4 seconds, we'd be going 5 miles per hour. After 4 seconds, we'd be going 16 miles per hour. Doesn't really make any sense. Or in other words, every input has to have exactly one output, or at most one output. So, is this a function? No. So this is not a function. I don't know why it's doing that. Yeah, it's not a function because there's an input that corresponds to 2 outputs, which is not good. So for part 2 here, it's the same idea, just different numbers. So do the same thing here. Domain, we started off with the curly braces, and we're going to list off the x values. I see a -3, I see a 2, I see a 3, and I see a 0. I'm going to go through this one a little bit more quickly. I hope you're all okay with that. The range, I see a 2, an 8, and a 3. And that last thing should be a curly brace. Say in a 3. Okay, cool. So the domain and the range, we have that again. So we ask ourselves, is this a function? Does every input correspond to at most one output? Looks good to me. I don't see any duplicates of the x values, so it is a function. So it is a function by that idea alone. One second. Okay, still hooked up with Google Meet, cool. Awesome. And for those of you who are, so I'm recording for everybody, I am recording everything that's on my screen right now. So I do post these to YouTube, and I will send up the link after I do so. Because as you notice, when I scroll up and down, the text does not follow. So naturally, I have to erase rather quickly. So if you don't have something written down, for those of you in class, or if you are in class, you can take out your phone and take a picture. If you're at home, you can you can take a picture of the screen, or you can use a snippet tool, whatever you use. Or you can just, if you didn't finish writing it down, you can just view the video later and copy down what you need to. But just to give you a heads up, I erase kind of quickly by the virtue of the setup that I have available to me. So kind of the unfortunate technological downside. But I'm going to keep this for now. I don't have to scroll anytime soon. So I'm going to move on to example 2 here, which is determine whether the equation defines y as a function of x. So here, there's no more ordered pairs. In fact, we have equations. Well, equation because we have an equal sign. And so, now what is the criteria? We do not have concrete x's to really look at and compare it to concrete y's. And so there's kind of a technical way of doing it. I don't really like it. I'm just going to tell you the pattern here. But primarily, y will not be a function of x if y has a square on it. When I say a square, of course, I'm not talking about a geometric idea. I'm talking about if y has a power of 2 or an exponent of 2. So hey, look at that for the second example here. The y, for the second example here, y has a square, or it has a power of 2. It instantly means this is not a function. So I'm just telling you that one. That'll help you do a few problems. But part 1 over here, this is a function because y, well, doesn't have a square on it. So there's a quick association that will help you with a few problems on the homework. But here's where I'm going to have to start erasing. So, well, hopefully you can write is a function and not a function fairly quickly. But if not, again, take a screenshot now, picture, whatever, or just review the video later. All right, so I'm going to erase. So now you're going to move on to example 3 here. And this now, so before we were looking at, well, kind of a way of identifying functions. And now we're going to figure out how to evaluate certain type of functions. And just familiarize you with some notational aspects of the course. So there's some equation up here. So they give us this function, and they want us to do a bunch of stuff to it. In fact, 5 separate things. So let's go ahead and start with part A here. So part A should be the easier one. So this says f of 4. So if you remember how that notation works, it means for that function that I have circled up there, I'm going to plug 4 into every occurrence of x that I see. So every time I see an x, I'm going to plug in a 4. And that is, in fact, 4 times 4 squared plus 3 times 4 minus 3. Notice every time I substituted, I used this set of parentheses. There's a reason I do this. I'm going to do it for the next parts. But just to give you a heads up that there is meaning to this. So every place I saw an x in the circled function, I put the 4. And so naturally, this is a bunch of numbers. We can solve it. 4 squared is 16. 16 times 4 is 64. Plus 12 is 76. Minus 3 is 73. So hopefully my math is right. So just a bunch of numbers. The answer is 73. So, all right, cool. Let's move on to part B. F of negative x, okay, well, it starts off a little weird because, well, it's not f of a number. What do we do? We just give up? So what did we do when there was a 4 there? We plugged in 4 for every x. So let's try and apply that same process. So that circled function that I had, every place I see an x, I am instead going to put negative x. Why negative x? Because I see a negative x there. Might need to write this a little bit smaller. Try that again. Okay, so 4 negative x squared plus 3, and again, I'm using these parentheses. I'm using these parentheses every time I substitute. If you were not to use the parentheses, chances are you would misinterpret the problem. There's a chance you might see 4 minus x squared, for example, in that first term, which is not correct. So that first term is 4 times negative x squared. And if you remember order of operations, what is that? Parentheses and then exponent. So that negative x squared here negative x squared times, or negative x times negative x, which is primarily what this represents. So try and think about what that means as I write out the correct answer below. So now that's 4 times negative x times negative x, which is positive x squared. So the negatives cancel. So negative x times negative x is positive x squared. And then we follow by looking at 3 times negative x. Well, 3 times negative x is going to be minus 3x. So notice that minus sign kind of worked its way to the front because there was nothing to cancel it out. And then there's that minus 3 in the back. That kind of does nothing. So really, this is the answer. I don't know why I have parentheses there. So this is the answer right here. And the reason I worked it out, the reason why I didn't stop at that first step, so there's a thing called MyMathLab that some of you may or may not be familiar with. MyMathLab is very picky, as those of you who have dealt with it are familiar with. It uses a very notorious word called simplify quite a few times. Simplify in MyMathLab terms is good enough is not good enough. So when it asks you to simplify, that means you have to reduce any algebraic inconveniences that may appear, such as that negative x squared that I have circled in red up there. So we're going to see examples of that in parts C, D, and E as well, but just wanted to give you an idea of why I kept going. Again, it's because MyMathLab is kind of picky. So from here, we move on to part C, which is f of x plus 2. So again, we think about what does it mean for x plus 2 to be in the parentheses? Well, what that means, so for the circled function up top, every place you see an x, you're going to replace it with x plus 2. And again, I am using parentheses every time I substitute. Plus 3x plus 2 minus 3. And so there's a lot going on here. So x plus 2 squared, there's a particular thing that we have to do to that. It's not just x squared plus 2 squared. We have to do something called FOIL. So hopefully you remember what FOIL is, because that's what we're going to do here. And to motivate it, So what is FOIL? Well, how do we even get to that form? X plus 2 squared is x plus 2 times x plus 2. And we're going to simultaneously distribute this 3. I'm going to illustrate that in red. I'm going to distribute. What happens when you have a number in front of a factor such as x plus 2? Remember, distribution means it gives you an order of numbers to multiply. So 3 times x, 3x, so 3 times x is 3x, 3 times the 2 in the back is 6, and then minus 3, because that was at the very end the whole time. And yes, we have to FOIL now, the x plus 2 times x plus 2. So I'll illustrate that as well. So FOIL means first, which is that first arc I just drew, outer, second arc, and the third, and the fourth. And just like what happened in my last class, we're going to ignore E for now. I need the space, so we'll come back to E. But we're going to keep going on part C here. So after we FOIL, so FOIL first is x times x, which is x squared. X times 2 is 2x. 2 times x is 2x. 2 times 2 is 4. And then there's a 3x at the end. And we have like terms at the end. 6 minus 3, which is positive 3. Positive 3. All right, very fun. You might also notice in the parentheses, there are like terms. I'll do that in blue. Looks nicer. There's like terms here. We can add them together and get 4x, just 2x plus 2x. And so, yeah. So that's all I did, just added the 2 x's together. Now I can distribute the 4. So x squared, 4x, and 4. Four times x squared, 4x squared. 4 times 4x is 16x. 4 times 4, 16. Plus 3x plus 3. Okay, and now we have like terms that we combine. 4x squared, there's no like terms for that one. I see a 16x and a 3x, which is 19x. And I'm going to squeeze in the 16 plus 3, which is 19. And that is our answer. All of that is for part C. Mainly, it's a lot of tedious algebraic steps. The steps individually should be familiar, but it's just the quantity of them in this problem that makes it such a hassle. So we'll move on to part D. which, same idea. We're going to plug in 3x for every function, or every x in the function, rather. So this will be 4 times 3x squared plus 3 times 3x minus 3. So that's the substitution aspect. 3x is substituted for every x. Okay, so like we did above, actually, in part B, instead of negative x squared, just noticed an issue with that. Parentheses should be there. That wasn't good. Oh. Okay, so like we did above, instead of negative x quantity squared, it's 3x quantity squared. So 3x times 3x. So 3 times 3 is 9. And the 4 is on the outside the whole time. So 3 times 3 is 9, and x times x is x squared. For the next term, 3 times 3x, which is 9x. And then there's that minus 3. Finally, we have 4 times 9x squared, which is 36x squared, plus 9x minus 3. And that would be the answer for part D. So I'm going to erase A and B, the work for A and B, because there's still part E that I have to do. Okay, so part E. So now we're going to block out A and B. What part E was asking was to find f of x plus h. You might think, come on, you had a variable, then you had a variable plus a number, now you have a variable plus a variable. I mean, yeah, that's what my math lab asks for, so I'm showing you it now. And so start off the same way as the previous ones. Every place you see an x, you're going to replace it with x plus h. I'm using parentheses to keep everything in a very particular format, so that way I know which algebraic situation to apply. So 4x plus h squared plus 3x plus h minus 3. And from here, I will have to consider foiling the x plus h squared right here. So, like I did before, I'm going to write it out as 2 separate factors, because that's what it means for something to be squared. I can simultaneously go ahead and distribute the 3 to x and to h, respectively. So that would be plus 3 times x, which is 3x, plus 3 times h, and then there's that minus 3 in the back. Now I'm going to start going ahead and erasing more stuff below. So again, if you don't have that all written down, please check the video. I'll post later. So now we're going to block out C, D, because we already did those. Now we're just looking at E down here. So let's keep going. We're going to FOIL. So FOIL first, outer, inner, last. The 4 is going to stay on the outside as we FOIL everything. X times X is X squared. X times H is XH. H times X is HX plus H squared. And then everything else follows. So all we did in that step was FOIL. That's all we did. Something else to notice, X plus H and H plus X, that's the same thing. XH and HX are the same thing. I think, does that make any sense? Well, it makes sense in the same way that 2 times 3 is equal to 3 times 2. Doesn't matter what order you multiply. So they're the same. And as such, they are like terms. Actually, I'm going to be a bit lazy here. So let's see. Blue, this is 2xh. So now I don't have to write all that out again. And now we can distribute the 4 to the x squared, to the 2xh, and to the h squared. After we do that, we're going to be done, because after that, there's going to be no more like terms. So 4 times x squared is 4x squared. 4 times 2xh, well, 4 times 2 is 8. And then 4 times h squared is 4h squared plus 3x plus 3h minus 3. And that is your answer. And so I picked the most complicated problem in the homework. So this is one of your homework questions. This is the most complicated one. The numbers might change, but it does illustrate the process that should be trickled down to the easier problems. So just keep that in mind. Not every problem is as rigorous as this one. I just chose one of the hardcore problems. And it's better I show you than you run into this just out of nowhere. So yeah, go ahead and have this written down, Google Meet people and people in class. I'm going to go ahead and erase it. Okay, cool. We'll meet people. Are you still hanging with me? Awesome. All right, let's keep going. All right, wanted to move on. So this is just descriptive for now. This is regarding interval notation. And some of you may be familiar with interval notation, some of you may not. If anything, I gave some cliff notes for what interval notation is and how to use it. And we're going to look at some examples right after this. But interval notation, so you're used to writing and representing intervals using inequalities. And you can see I have the inequality symbols written up here. But there's honestly a much more simplistic, at least aesthetically simplistic form that we can use called interval notation. It's compact, it's convenient, and most importantly, my math lab will request it for the rest of the semester. So you got to figure out interval notation now. So, and again, I provided some cliff notes for interval notation. So each number in interval notation is going to be accompanied by, well, actually, let me start off with this. Interval notation has a pair or pairs of numbers. So no number is really going to be by itself. Each number is accompanied by either a bracket or a parenthesis. You put a bracket if the number is included in the inequality, such as if you had a greater than or equal to sign, as opposed to just a greater than sign, which means you would use a parenthesis. So for every number, it has either a bracket or a parenthesis next to it. Smallest number always goes to the left, largest one on the right. You don't have variables in the notation. So no variables in the notation. No variables, only numbers in the infinity sign. So we'll see an example of that in a bit. Disjoint intervals are, so if you have an inequality over here and an inequality over here, and then you just converted both of those to interval notation, you glue those together using this U symbol, which will be accessible in my math lab. It's called a union. It's ways to glue disjoint intervals together. And we'll see an example of that momentarily. The most applied example or situation of interval notation is domains, finding the domain of a function. We mentioned domains before. So we mentioned domains before, but now we're going to algebraically determine domains. And I like to do things as sequentially or as streamlined as possible. So I did my best to relegate domain-based problems down to pretty much a checklist of 4 different situations. And knowing which one to use, so you can see them enumerated 1, 2, 3, and 4. If you can identify the form that you're given, well, you follow these directions and it'll give you the right idea of how to begin. So we have some criteria to consider. The first one says, if the function has a variable expression in the denominator, so these are problems that ask you to find the domain of a function, as you can see in example 4. If you're asked to find the domain of a function and you notice that there is a variable or variable expression in the denominator, then you're going to use whatever part 1 says here. So what it says is set the denominator not equal to 0 and solve for x. That's the criteria. If you see a variable expression in the denominator, and I have an example of it right here, then take the denominator. And in fact, as I'm saying this, I will simultaneously write it out. So you have this. Enlarge this a bit. Let's see, control. One second. Well, so I'm not zooming in. Never mind. All right. So, regardless, it says set the denominator. So what's the denominator? The denominator seems to be x to the third minus 64x. Set that not equal to 0 and solve for x. Notice the numerator doesn't even matter in this problem. We're pretty much taking the original function and just tossing it, because now we're looking at the new thing that I just wrote down, the x to the third minus 64x not equal to 0. That's what we're looking at now. And we have to solve for x. So to solve for x here, well, we have to think about some of the basic factorization techniques. So the way we start, well, I noticed that both terms here, they have something in common. Yeah, they both have an x in common. X cubed, well, it has plenty of x's. The minus 64x also has an x. So we're going to factor out an x. And it's going to look just like this. We factor out an x, that's a parenthesis. We had x cubed, which is 3x's. I just took an x away. So that's x squared. And then minus 64. And it's just 64 now because we took the x out. This is, and if you were to distribute, you would get right back to where you started to verify that you factored out correctly. So really what we have is a factored form, which should be familiar. So the reason why factored forms, the reason why we factor in the first place is because you take a larger problem and you break it down into simpler components. This problem falls under that exception. And how do you break this problem down? When you have a product of things equal to 0 or not equal to 0, you can break them up as each part of the product gets its own equal to 0 or not equal to 0. So I'm just going to write that out. There's a product here between the x and the x squared minus 64. Just put a dot there. The x gets its own not equal to 0, and the x squared minus 64 gets its own not equal to 0. That's why we factor. We factor because we utilize this property that allows us to deconstruct larger problems into smaller components. And even more fortunate for us is one of these components is already solved for. X is already isolated. So we already have one of the answers. But the x squared minus 64, well, that's something we have to figure out. So let's see, I'll do that over here. So some of you, perhaps the more astute algebra student, may see the answer immediately or may think of a difference of 2 squares. If you have no idea what I'm talking about, that's okay, because we can just use basic algebra. We can add 64 on both sides. And then we take the square root to get rid of the square on the x. So we apply a square root to get rid of the square on the x. So you might think, all right, the square root of 64 is just 8, and we're done. But there's negative 8 as well, that pesky plus or minus business that happens whenever you take the square root of something. Yeah, so whenever you apply a square root, you inadvertently apply a plus or minus, which is why there's 8 and negative 8. So now we have 3 answers in total. We have 8, negative 8, and 0. Well, we're using MyMathLab. So did you think it was going to be that easy? No. MyMathLab says, I want the answer in interval notation. We do not have an answer in interval notation yet. I'm going to erase what's on the left side of the screen here, that x cubed. I'm about to erase all of that. So go ahead and make sure you have that jotted down, or keep that in mind that I'm erasing that, because I need more space. So I'm going to emphasize, we found that x did not equal 0, -8, or 8. But this is not interval notation. And we don't even know what interval notation is, at least relative to this construction of the course. So what I'm going to do, so this is an inequality. I'm going to draw a number line. Number lines are normally really helpful when constructing interval notation. That's why I'm doing it here. And what are the three numbers in question? Let's see, -8. I see 0. I see 8. I'm putting them in order because the number line is ordered. I'm putting them in order. Are these numbers included in the interval or excluded? Or is there excluded? Because not equal. X is not equal to them. So I'm going to draw an open circle, open circle, open circle. So when I say that X is not equal to these things, it sounds very glass half empty. Let's view the converse of that. What would be included? If X is not equal to those three things, yeah, X could be anything else. That's quite a, that's quite a lot of numbers. So in red here, there's this interval over here to the left of -8. There's this little segment in between -8 and 0. There's this interval between 0 and 8. And there's this interval after 8. That's 4 different segments I've just identified. So that means we're going to have 4 interval notations. Again, I picked the hardest problem. The other ones are much, much easier than this, I promise. This one's the hardcore one, so. In fact, actually, I'll do what I did in the last class. Let me use, yellow's ugly. I'll use purple. So I'll use purple to kind of block off. Might be hard to see, but I want to denote that first segment first. The one on the far left. So what is that segment? So it's the segment from, so what's the furthest left we can go? That's -infinity. Because notice that arrow on the far left, that's red, which means it just goes to the left forever. What's to the left forever? You can equate that as -infinity. And then what's the furthest to the right you can go until you hit some issue or some stop? It's -8. So I'm reading it from left to right. So let me use purple and kind of explain how I'm reading this. I'm going from left to right. So I'm going from left to right, and I'm going to stop whenever there's some sort of situation going on. -8, there's a situation going on. So the furthest left I was going was -infinity, and then I have to stop at -8. So I'm stopping at -8. Now, when I was talking about interval notation, I mentioned that every number and infinity as well has either a parenthesis or bracket corresponding to it. Infinity will always have a parenthesis. So I'm going to put a parenthesis there. Parenthesis means not equal. Makes sense. You will never equal infinity. Infinity is not something that's concrete. Infinity is an idea. negative 8, is negative 8 included or no? It's not included because we said x is not equal to it. So negative 8 gets a parenthesis. Parenthesis, of course, means not equal. All right, so we're still reading left to right. So where did we stop off at? We stopped off at negative 8. And we keep going until we hit another issue. And then we stop at 0. So that's what I'm using this kind of colored multi-layer step here to illustrate. And so now that interval, we started at negative 8 and we ended at 0. And they all get parentheses because none of them are included. They're in particular excluded. But hey, look at this. We have two disjoint intervals. How do we glue those together? Use the U. That U notation. And if you were to keep going, you would start off at 0 and go to positive 8. And then you would start off at 8 and go to positive infinity. That horrendous notation, that whole thing with the U's and everything, that would be your answer for this problem. Interval notation takes a little bit of getting used to. Next problem, the interval notation is much nicer. Maybe next time I write these notes, I'll switch the square root and the fraction thing. All right. So again, that's the hardcore one. The other ones like that are much, much more simplistic. And if you send me an email about a question of that caliber, it's going to be a lot less work than this one. Okay, so that's one criteria whenever there's a variable expression in the denominator. This is the general step process to do. You set the denominator not equal to 0 and you solve for x. It just so happens in this problem, solving for x was solving for x in the interval notation was the primary issue. But setting up the problem is pretty much straightforward, I would think. There's another situation, much easier situation. What happens when you have a square root and you're trying to find the domain of a square root function? So that's part 2 here. That's what that addresses. So it says if the function has a variable expression under a square root symbol, which is what example 5 has, set the radicand greater than or equal to 0 and solve for x. What in the world is a radicand? Sounds like a Pokemon. So a radicand in actuality is everything under the square root. That's what a radicand means. Everything under the square root. So with that newfound knowledge, what's everything under the square root? It's 4x minus 16. That would be the radicand. And it says set the radicand greater than or equal to 0. Solve for x. Well, hey, that's not too bad. Looks like a fairly manageable inequality that I can solve for. So let's see. That's 4x is greater than or equal to 16. When you add 16 on both sides, and then dividing by 4, which I'll put over here, we get that x is greater than or equal to 4. I think at least, if anything, those steps should be the slightest bit of normalcy in comparison to everything else. So, but of course, this isn't good enough because my math lab says, pretty much it says, I want interval notation. This is not interval notation. This is an inequality. So instead, so this is what we had. I'm going to convert this to a number line. I'm going to express this using a number line. I like using number lines as a way to convert It's a nice illustrative manner. If you don't need the number line and you just see it straight away, then go for it. But I'll do what I did last time. In blue, I'll jot down all the important numbers. I see 4. See a 4. I don't see any other numbers, so I just put a 4. And then what we did last time, and what I'm going to do here as well, is 4 included or excluded. Looks like 4 is included. There's that little equal to part. So I'm going to put a filled-in circle here instead of an open circle. And finally, we need to figure out which way to shade. Well, here, x is greater than or equal to 4. So it's a number that's greater than 4. 5 is greater than 4. 5 is to the right. So that gives us an idea that we're shading over here. These are the numbers greater than 4. So it makes sense that we want to illustrate and shade in the appropriate manner. So that region in red is what we now have to represent in interval notation. So that part I have in red. What's the furthest to the left? What number is the furthest to the left of that red interval? And that number is 4. That red interval, the furthest to the left we can go is 4. And before I use parentheses or brackets, let's think about the furthest to the right we can go with this red interval here. The furthest to the right, it's positive infinity. It just goes to the right without any restriction. Infinity always gets a parenthesis, no matter what. Same with negative infinity. And 4 here is going to get a bracket. Not a parenthesis, a bracket. That's because 4 is included. So use a bracket. And that would be your answer. A lot nicer than the previous problem, no doubt. So go ahead and jot this down. I have one more to do. I'm going to erase this. So if you don't have this written down, please view the video or something. All right, so like I said, I have one more problem. Get done with this, I'll be caught up. All right, so there's a third condition, fourth condition, there's no work. So there's this third condition about what happens when you have pretty much a metamorphosis between the previous two conditions. If you have a square root function in the denominator. So first one, we dealt with denominators. The other one, we dealt with square roots. Now what happens when there's both? It says set the radicand, there's that word again, strictly greater than 0 and solve for x. In this problem, what's the radicand? It's just x plus 9. Everything else in this problem is insignificant. It says set the radicand strictly greater than 0. That's what the condition says. It tells us how to build the inequality. And from there, well, this is a pretty manageable problem, I think. So we obtain the inequality fairly quickly. From here, the significant number is -9. We're going to put an open circle at -9 because -9 is not included. There's no equal to. And we shade to the right because x is greater than. And since I'm out of time, -9, comma, infinity, with the parenthesis on the -9. The fourth condition just says if none of the previous three happen, then the domain's all real numbers. And you put exactly that. So it just tells you what to do if none of those three conditions are met. You just get the answer for free. And I'm all caught up, so I'm happy about that. That's all I have for today. In-class people, if you have any questions for me, go ahead and prop open the door. Oh yeah, there's no rule sheet, by the way. If you catch Corona, you gotta email me though. Now I gotta do some paperwork.
Oh, can we go on Zoom tomorrow?
For tomorrow's session, that means that, yeah, for Wednesday's session, you would do it virtual. You could show up here and see if there's available seating if you want to do both days, but the priority goes to anybody who is in good mood. What's that? I sent out a link. Would you accept?
It's probably somewhere. It's probably after. I have some emails.
Check your Google Calendar. It syncs up with your Google Calendar.
Okay.
So that would be the first place to look.
Okay, thank you.
All right, my Google Meet people. Let me check in 1 second. Google Meet people. Okay, for the remaining people in the Google Meet session, did any of you, and you can chat. You can use the chat option if you have any questions. Otherwise, you can just shoot me an email. But if I don't get any questions in like a minute, I'll go ahead and close up.